Okay, so now we're moving on to example 2, which is evaluating a trig expression. So they want us to find the exact value of cosine of u minus v. So they're telling us which property we're going to be using. And they're giving us cosine of u equals 15 over 7. And it says u lies between pi and 3 pi over 2. And which, by the way, if it lies between pi and 3 pi over 2, we're looking at quadrant 3. And then sine of v equals 4 over 5, and that lies between 0 and pi over 2, which is in quadrant 1, okay? That actually matters because it'll pretty much tell you where you're going to be drawing your picture, okay? So here we go. Since we're using cosine u minus v, again, refer to your index card or to page 377. So cosine of u minus v basically looks like this. Cosine of u times cosine of v plus sine of u times sine of v. So let's actually put that right now. Okay. So according to this, we have cosine of u times cosine of v plus sine of u times sine of v. So let's actually substitute what we know, okay, or what we're given. So we're given cosine of u. So for cosine of u, we're going to write down 15 over 17, okay? And we're given sine of v, and that's 4/5, so we're going to write 4/5. So now we have to figure out cosine of v and sine of u, okay? So for that, we're going to be using, I'm going to be using actually a whiteboard. So we know that cosine of u is 15 over 7, and cosine is adjacent over hypotenuse, and that's going to help us find sine of u. And of course, sine of u is actually opposite over hypotenuse. So technically, we have our hypotenuse at 17, okay? And remember, we were given the restriction that cosine of u lies between pi and 3 pi over 2. So we're looking at quadrant 3. So I'm just going to draw that real quick, okay? So basically, we're going to have our triangle here, okay? So this is u, and then adjacent is 15. So adjacent to angle u, it would be here. And then hypotenuse, which is 17, would be here. And then we are going to find the opposite side, which is here. So I'm just going to call this x, okay? By the way, since the adjacent side is here, that is going to be negative, okay? So that'll be negative 15 over 17. And as a matter of fact, I think that's what it should have been. Give me a second. Okay, I noticed I wrote cosine of 15 over 17. That needs to be negative, and I apologize for that. Okay, which means over here needs to be negative. Okay, and luckily I was able to see that error as soon as I drew my picture. See, so that's another reason why it's good to draw your picture. Okay, so all you have to do is do the Pythagorean theorem to solve for your x. So doing the Pythagorean theorem would be, of course, this would be our a, our b, and our c. Okay, so here we go. Again, I'm just doing Pythagorean theorem. So x equals 17 squared minus negative 15 squared. And then you want to take the square root, okay? So I'm isolating x. And you can do that in a calculator. So let me grab my calculator. Okay, so if you have a calculator, you can put it all in at the same time. And that'll give you 8. And that, of course, it'll give you positive 8. But if we're in quadrant 3 going down, we want to get negative 8, okay? And that's another reason why the domain that they gave us matter, because although I am going to put this in my calculator, which you guys clearly saw, it did give me positive 8, but because we're in quadrant 3, it's actually negative 8, okay? So basically over here, we're going to put negative 8, which means when we do sine of u, we should have, ready, negative 8 over 17. And so now all we have to do is find cosine of v, okay? And of course, we're going to use sine of v to help us find cosine of v. So similar to what we just did. Okay, so now we're going to use sine of v, which was given to us, which is 4 over 5, to find cosine of v. And if you notice, they restricted the domain. So sine of v is between 0 and pi over 2. So now we're looking at quadrant 1. Okay, so I'm going to draw my triangle there. V would be here, my angle of reference. And then opposite would be here, 4, and the hypotenuse would be here, 5. Okay. And again, you would do Pythagorean theorem to solve for x or your adjacent side. Now, okay, you can do Pythagorean theorem. This is actually a what we call like a special right triangle. This is one that's very common. So I actually know this one. This is 3, 4, 5. So x is actually 3. Okay. And again, it just kind of helps me, but you could do Pythagorean theorem. So this is going to be 3 over 5. Okay. So now cosine of v, and sorry if there's a glare, cosine of v, I'm trying to move it so there's no glare. Cosine of v is 3 over 5. So now, drawing our triangles just helped us solve for the other two missing sides. So now we have everything that we need. Let's plug it into the formula. Okay, so cosine of v should be 3/5. Okay, it's up to you if you want to put in the calculator all this and get an answer. Okay, I'm going to go ahead and just do it by hand. So if I look here, the only thing I could simplify is the 5s, and this would be 1, and this would be 3. So now I end up with negative 9 over 17 plus, and the only thing, actually I can't simplify anything. So this would be negative 32 over 17 times 5, and I'm going to need a calculator for that. That'll give me 85. Okay. And now just follow the rules of adding fractions. So it's up to you if you want to keep doing it by hand or just put in a calculator. At this point, I can put it in the calculator. So I'm going to end up with negative 9 divided by, oops, I'm using the fraction tool. Plus, and then math, negative 32 over 85. Yeah, okay. So my answer is negative 77 over 85. Okay. And that should be my final answer. Negative 77 over 85. And that's it, boys and girls. Okay. So let me just kind of reiterate what we did. Okay, so we were told to find the exact value of cosine of u minus v. We were given cosine of u and we were given sine of v. And each one had a restricted domain. So this one lied between quadrant 3 and this one lied between quadrant 1. And of course, we drew our triangles in each quadrant to help us find our missing trig functions. So to help us find cosine of v and sine of v. And once we got those, we just plugged it back into the formula to get exact values and then just simplified. And we got negative 77 over 85. Okay, so follow the same procedures and try the checkpoint on number 2 and then check your answer. And again, if you have any questions, come see me.